Okay, so central force motion. Today we will talk about the energetics. So when we are talking about energetics, what we mean is the total mechanical energy total mechanical energy particle of mass m. This is the particle in question. So like you know, the coordinate systems can be chosen as polar coordinate system for this particular problem, and your velocity vector will have components both in the e theta and er direction. So your v is r theta dot e theta and r dot r. So what is the kinetic energy of the particle? Half m v dot v, and this gives the kinetic energy as half r square theta dot square r dot square. The way we define potential energy, if you recall, we do it for most of the potential. We assume we take a datum, like we have always said, datum or reference for potential energy must be chosen. It is chosen. And it is chosen as V equal to 0 when R tends to infinity. So when this particle is much far away from this planet, the potential energy between the planet and that particle is chosen to be 0. Very far. Now what happens if that is 0? Okay. Then let's say you slowly start bringing the particle towards the planet. Okay, you slowly start bringing the particle towards the planet. Okay, so in that case what happens is that it is an attractive force. Picture the particle approaching the planet. Okay, and that is an attractive force. So as you are away, the attractive force is minimum. As you start approaching, the attractive force increases. Okay, so what happens, there is a tendency for the particle to accelerate towards the planet. From infinity, it will have a tendency to accelerate towards the particle. Okay, so here acceleration matlab kya? Velocity is increasing or decreasing? Increasing. So kinetic energy, is it increasing or decreasing? Increasing. So work done by the gravitational force, is change in kinetic energy, and this kinetic energy change is positive. And we have known that for conservative systems, work done by gravity, now here this work done is positive. Why? Because here is the planet, it is exerting attractive force, and the planet is approaching the particle is approaching the bigger massive planet. So this is a positive work done, right? And you can express this as negative of the change in potential energy. That is true for any conservative force. Work done by the conservative force can be expressed as negative of the change in potential energy due to that force. Okay, so this is how you actually define potential energy for conservative forces. You know that for non-conservative forces, the definition of potential energy does not hold, right? We define potential energy only for those forces which are conservative. Work done by in the round trip is 0. Okay, so if you replace it over here, what you end up with is 0 equal to del T plus del V. Why? Because this was minus del V. So it is 0. Now change in kinetic energy was positive because it was accelerating. The left hand side is 0. That means the potential energy change must be negative. Right? The potential energy change must be negative. So final and initial. So your Vf minus Vi must be negative. You seem to be troubled a little bit. कोई बात नहीं. If something is not making sense, you can ask. पोटेंशियल एनर्जी नेगेटिव कैसे हुआ? जो वर्क ये नेगेटिव होगा तो नेगेटिव और नेगेटिव तब क्या होगा? पॉजिटिव होगा. तो वर्क डन तो हम देख रहे हैं ना, व्हेन इट इज अप्रोचिंग द प्लैनेट the work done by the force on the mass is positive, क्योंकि force भी इसी डायरेक्शन में है, displacement भी इसी डायरेक्शन में. ठीक है, so it is a positive work done. And you express work done by conservative force by definition of potential energy, that is by definition as minus of negative of the change in potential energy. तो del V को तो negative होना पड़ेगा, तभी work done positive होगा. Here also, if you keep it, you place it this side, del T was positive. Why? Because when particle is approaching this mass, it is accelerating, right? तो काइनेटिक एनर्जी तो पॉजिटिव होगा ना एक्सेलरेशन में. ठीक है, तो काइनेटिक एनर्जी पॉजिटिव हो गया. ये अगर नेगेटिव नहीं होगा तो राइट हैंड साइड 0, सॉरी लेफ्ट हैंड साइड 0 नहीं होगा. ओके, so by the definition of this datum, we have chosen this initial at r equal to infinity. यहाँ पे हमने choose किया and we have chosen this to be 0. तो Vf क्या होगा? Negative होगा. And that's why this V is given as minus Gm, if this is capital M, by R. You check the expression when R tends to infinity, V is 0. For a finite R, it is negative. Here there is one important thing. This is only the definition of potential energy. R infinity में हम लोग उसको choose किए हैं 0. हम लोग नहीं भी कर सकते, but that was the convention which is being followed. For finite R, we are that's why getting negative. This entire thing is the explanation of why there is a negative sign. Infinity में 0 है. Then when the particle starts under the application of attractive forces, it starts accelerating, so potential energy will be negative, right? Because of the work kinetic energy theorem. for a finite R, or especially the total mechanical energy at point B must be half m r square theta dot square plus r dot square minus g m by r. Sometimes you can write gm like I have stated countless times as gr square, where g is the acceleration due to gravity at the surface of the earth. Okay, so you can further write the total mechanical energy at B is half mr square theta dot square r dot square minus g r square this is the total mechanical energy. Now after the burnout, after it has started from A, this is the free flight, right? और free flight में conservation of energy is at your service and conservation of momentum is also at your service. So you can conserve the total mechanical energy at point A and point B should be the same. Once all the rocket has burnt, all the fuel has burnt, now it is starting with a V naught. From that point on, once all the external thrust is taken up by the fuel, okay, and only this V naught is the initial condition, initial kinetic energy which is imparted. So from A to B you have conservation of mechanical energy. So since it is a free flight, E at A should be equal to E at B. Whatever is the EB, that should be equal to EA. Now when you want to write EA, which is equal to EB, what can you say about the energetics at point A? A में भी kinetic energy होगा, potential energy होगा. So tell the kinetic energy of this. Half mv naught square. Okay, half mv naught square. And what should you write? Okay, or you can write, even if you write mg r square by g r naught, that is also correct. So you can also write this as here. I want to ask you, what is r dot equal to at point B? Here this V is tangent to the trajectory and it is having components along theta and along r. Along r component gives r dot. Here the velocity is having component like the total velocity vector itself is along e theta. There is no component along r. तो r dot क्या होगा? 0. So you can further write this as half m r square r naught square theta dot square and what is theta dot? R square theta dot is h, theta dot is h upon r square. Yes?
H square.
H upon r square. So half m r naught square, you can write here r naught. So this is theta dot square, so it will become h square so you get half m h square by r naught square minus mg r square by r. So this is Ek, which is finally equal to Eg. Next part, you know that R naught at theta equal to 0, R minimum is R naught instead of writing Gm by h square, I am writing Gr square by h square. So I will replace 1 by R naught by this expression. Okay. What I will do, I replace this. So let's say 2 and let this be 1. So you substitute now we will resolve this A and B, because finally the total mechanical energy throughout the free flight is the same. So A पे है, B पे है, doesn't matter, the total mechanical energy is the same. Okay. So you will write half m h square why is this whole square? Because it is 1 by r naught square. Now you expand this. Now you expand the bracket or start multiplying. Now you know that CH square, let me write it. There is no space here, but what I will do, okay, let me write it later. See what I have done, I have just expanded this and I have done this part. This part I need to do, right? So here you have to, let me just write it separately. So this you end up with mg square. So this part over here, this particular part you replace with this part. Okay. Still confused? So you can see that here you have mg r square c, here also you are having mg r square c. Then you are having minus of mg r h square and 2h square. This term is greater. So your finally you will get E as half m h square c square minus mg square r to the power 4 by, because here you multiply by 2, 2h square, 2 is there with the minus sign, so it becomes a like fraction. And finally this expression comes out to be, sometimes my own markers get mixed with the public markers. I have a hard time. 2 upon m c square h square you will be wondering कि सर आपने V फिर लिखा क्यों? Okay, why I wrote V? To show you that here there is a R dot term. Why I wrote energy for A separately? To show that there is no R dot term. So if computing energy at point A, of course, is simple. You are launching the space vehicle. You know the velocity v0, आपको launch location भी पता है r0, so with v0 and r0 you are able to write the E. You note that this E depends on C and H, and C and H you know previously can be fixed once r0 and v0 is known to you, and these are the launching conditions. Okay, so the launching conditions, with that you know the total mechanical energy, and that you can equate for some other point which is not R minimum. Some other point where R is not equal to R minimum. When R is not equal to R minimum, R dot is non-zero. Only at R equal to R minimum, R dot is equal to Here please write r dot is equal to 0. ठीक है, ये तो आ गया, बट अब इसका और क्या क्या कर सकते हैं, दैट इज द थिंग. You have copied this. Otherwise, even if you forget, I'll be here on that day during that time. Okay. Now what will we do? E m is c square h square minus g square r to the power 4 by h square. Okay. Now what you know is ch square by gm, if you recall in the previous class, was equal to the eccentricity, and this you can further write as ch square by gr square. So here what you do, you substitute c. So in this expression you substitute Why are we doing this? We want to comment on the energetics which is contained by different trajectories. So you have E G R square by h square, and this you can substitute over here. C is being substituted, and you end up with you will get E square G square R to the power 4 H to the power 4 minus G square R to the power 4 G square, oh there is a H square here, so this H square cancels. Finally you end up with G square R to the power 4 by H square is therefore your total mechanical energy in central force motion is given by Now, what is the energetics, what is the total mechanical energy when your E is greater than 1, that is hyperbola. Hyperbola, it is positive. For E equal to 1, parabola, when you are having the escape velocity, now dwell on this. Our definition of potential energy was such that at R equal to infinity, the potential energy is 0. That was definition of potential energy. Now hyperbola says that E will be always positive. तो अगर यहाँ पॉजिटिव है E, तो इंफिनिटी में भी पॉजिटिव होगा, वही वैल्यू होगा, एनर्जी इज बीइंग कंजर्व. तो R इक्वल टू इंफिनिटी में पोटेंशियल एनर्जी क्या है? What is the potential energy? Zero. So how is energy positive then? Kinetic energy. मतलब R इंफिनिटी में वो the space vehicle is still moving. यही पैराबोला में क्या होगा? No velocity. Why? Because it is zero. R infinity में potential energy is zero. Kinetic energy also has to be zero. तो escape velocity का और एक definition क्या होगा? कि the minimum velocity. Why it is minimum? क्योंकि उतना minimum velocity देने पे R infinity पे kinetic energy zero होगा. That means it is just the velocity which is needed to move the space vehicle to infinity. Just the velocity. तो just तो तभी होगा ना जब पहुंचते पहुंचते वो zero हो जाए. But if you are giving velocities more than the escape velocity, then at r equal to infinity it will be having some right velocity. So that is a insightful thing, at least to me. But then when will you get E less than 0? When? So it's a ellipse. And at E equal to 0, it has a constant value, of course. Even for ellipse it will have a constant value. We will see that. E equal to 0 में क्या होगा? Energy का value, this part will be 0, right? So it will be minus g square r to the power 4. ये यहाँ पे 0 करने से जो होगा, that will be the value of energy for circular orbits. Now let us for an ellipse, so if you write 1 by r c plus gr square upon l square. What is this r in terms of the properties of the ellipse? A 1 minus c. Further, you can also C is known to us here. We have to get the ellipse in terms of energy contained by a ellipse as a constant value. So we need to eliminate the value of E. How do we eliminate the value of E? Sorry? But in my final expression I don't have C, but what I know is Cn square is EGR square. Right. So I can write E check if you are getting this. You take gr square by h square common, this becomes 1 plus e. Take it this side, it is 1 by 1 minus e square. So from here you get e square minus 1 h square. Check this. Okay. Now what we do here, if you replace this e square minus 1, so you substitute this in 4. You get what you get, e for the ellipse. Tell me the expression. Minus m g r square by 2a. Yeah, appears to be correct. Nice and cute expression for the energy of the ellipse, minus mgr square by 2a. So what does this mean? That if you look at the size of the ellipse, which is dictated by the semi-major axis, so if you are having a greater semi-major axis, that means more energy is being pumped to create that trajectory. You have to pump some energy at point A. Okay. And for this 5 you can use for problem solving. So equation 5 can be used to apply conservation of energy. Okay, conservation of energy. So at any point your speed of the space vehicle is half mv square minus mg r square by r equal to this E ellipse. This you can apply for any point, right? For any point on the ellipse. इसमें r dot क्या होगा? Will be r dot for any point on the ellipse. r dot होगा कि नहीं होगा? r dot होगा. तो r dot गया कहाँ इस एक्सप्रेशन में? वो भी तो है. Like he said, भी तो है. डरने की कोई बात नहीं, भी है. So he has both r dot square plus r square theta dot square under root. Right? So the v is there and the radial distance is mentioned. So you can use this for problem solving. You can take one step further and write expression of v. Ellipse में velocity of the space vehicle, unlike circular orbit में क्या था, हर जगह वो root gm by r naught था. But here what it is, 2 by m mg r square by r minus r minus, please check this expression, gr square को बाहर ले लिए, okay, m cancels, 2 gets multiplied, so I think that is all for today. Or you can also write this in one following way, 2gr square, and also write like this. Same. Now from this expression, when r is maximum, then what is this particular expression? This becomes minimum, right? So when this is minimum, v becomes minimum for maximum r. R maximum मतलब 1 by r will be minimum. R maximum मतलब क्या होगा? apogee या perigee? Apogee. R max, remember peri मतलब near. So R max means apogee, and at apogee 1 by r is minimum, r is maximum. So this term gets reduced and gets deducted by a constant term. Similarly, when r is minimum, 1 by r is maximum, v will be maximum. R minimum matlab perigee, and velocity is more at the perigee. That also conforms with and corroborates your equal areas in equal time theorem. Okay, so you can replace r also as a into 1 minus e, a 1 plus e, and get velocities at the apogees and perigees of the satellite. ठीक है, ये इतना सब समझ में आ गया? बहुत बढ़िया, वेरी गुड. So all of you are appearing for gate? Huh? You're shy to raise your hands. So we had some gate aspirants also in the previous batch. So every year I think now it's a trend. So